My name is Magnus Chung. I'm the CISO or the CISO of Wired Network. Pleasure to meet all of you. So, this is not my presentation. I was looking at that, I said it'd be really bad if I didn't know the thing I was presenting on, but now we're getting there slowly. But while they figure that out, one of the hardest parts of my job is actually trying to tell people what we do. They always say, "Oh, Magnus, nice to meet you. What do you actually do? What do you work on?" So today I made a very simple, super simple. I've seen a lot of these diagrams that are actually pretty complicated. Mine is very simple. And it's a little diagram saying, hey, this is, oh, here we go. There we go. This is a little diagram showing, see if this works. Bam. This is the internet on the right side here, and what I'm going to be doing some parallels to is blockchain and how we are approaching the problems on the left side. So it's very easy. So because we do things from a hardware perspective, we do protocols, we build applications. From a lot of people, it's a lot of different things that we work on. So this is a very easy comp. Usually, when people think about the internet, they think about this one thing, but there's an incredible amount of dependencies that are there. So I know my talk says ecosystems and interoperability, but I'm just going to go through here real quick. So we have our version of applications that we've been building, really amazing partners like Medikey, for example. dApps. We have our own protocols that we are building. One of the most notable is UPAP. I'm going to talk about that in a second. Universal Polymorphic Address Protocol. And the last thing is the nodes that we run everything on. So actually, I like to do this presentation a little bit backwards. So I'm going to talk about the nodes. So everything sits on top of the nodes in any kind of system, whether you have twisted cables, Ethernet, and then you have PPP that sits on top of that. That's over on this right side over here. And then on top of that, you have like protocols like RTP, you have HTTP, everyone knows that one. And then you have the applications that sit on top of that, like your Chrome application, for example. So same thing for Web3. We have these nodes. And it's really important to us because we believe in open source, we believe in trustless, so the devices themselves should be trustless. A lot of the responsibility of the hardware has been pushed onto the miners, and we don't really particularly believe in that for ourselves. So, oh, by the way, there's a QR code here. And at any point in time, if you want more information, more detail than what I'm showing up here, then please feel free to dig around and do so. Right. But essentially, the nodes themselves are trustless, which means that you can verify everything about it. We don't use any proprietary software, and everything in the hardware is verifiable. So that's very important. So we start with a very clean and open source foundation. Then we have been building protocols such as UPAP, which is, again, stands for Universal Polymorphic Address Protocol. Essentially, and the .io is, you can go look it up on that site, but essentially what that means is universal addressing. So instead of having 6 Chrome extension wallets, you can have 1 Chrome extension wallet, and that wallet can access all blockchains. And it's not like an EVM. It can access EVM-compatible chains. It can access EOS-compatible chains. It can access whatever you want, substrate chains, parachains, whatever you like, as long as they are open source as well. So I could talk a little bit more about that. But those are part of the protocols we are developing. And of course, we're developing these dApps that sit and utilize these protocols and then are operated by these nodes. So some of the partnerships that we have formed is with Medikey. Medikey, actually, our partnerships is better most talked about with Ken, our CEO. He's going to be coming up here in a second. Medikey R4R3 is a wonderful marketplace that we have. Perk is a human capital protocol. We have IPFamba. They are a IP score protocol. Mandocs protocol for artists. So we have worked and selected partners in our ecosystem that are great and phenomenal leaders in their kind of Web 2 industry, and we help them transition to the Web 3. So actually, I do a lot of that. I help them out with that a lot. So essentially what I say is this is what your network or your app will look like on this network, this network, this network. And we show and talk about UPAP, universal addressing. We talk about our nodes, how they're trustless. And generally, they come to the consensus that we would love to be built on your network, which is really heartwarming for us as we are a team of engineers down in Florida. So, again, talking about Universal Polymorphic Address Protocol, that's a very interesting protocol that we've been working on. And essentially, we abstract ownership and utilize a name service contract, so we have bridgeless interoperability. That is really, really cool. Bridges tend to be a little bit centralized and can become an attack vector. So by utilizing bridgeless interoperability, we've been able to avoid such pains. So that's a really big flagship product. We have developed a lot of other protocols, but as far as the main one that we've been promoting, this is the one that we would like everybody to adopt. And just so everybody knows, protocols are to be used by everyone. That's the point of the protocol, if you don't know. And a lot of you here are developing your own amazing protocols, and I wish for your protocols to be adopted. And if you provide a solution, then we would love to integrate that into our network as well. So I hope to collaborate with a lot of you there. And yes, this comes down back to the nodes themselves. The nodes are limited because the hardware, they're actually limited physically by hardware. So there's physical amount of CPU, net, and RAM. And then as the network expands, is what we call a network expansion. Basically, there will be a rolling average around 65% or more. Then we'll be able to roll out the second phase of our node sale. But right now, we have 21 T1 nodes, 84 T2 nodes, and then 1,000 T3 nodes that represent physical space on the network. So I would actually, at this time, like to bring up our CEO, Ken DeCross, to speak on our node sale.
Hi, everyone. I'm Ken DeCross, again, CEO of Wire Network. And Magnus touched on a few things, but there's two key elements that I feel like everyone in this room should understand and be really excited about. And that is, he mentioned it before, but it is bridgeless interoperability. No, I've been here all day listening, and no one else has talked about this. They've either talked about what bridge they're building, how to make a better bridge, or sometime in the future, these bridges will get to a point of security where they won't be hacked for hundreds of millions of dollars. So we decided many years ago that once we saw these bridges being built, we knew that there was an attack vector. And so what we decided to do is said, we don't want to make the next incremental development in blockchain. We need to have something completely foreign that solves these solutions. Bridges will never be a thing. They're always going to get hacked. There is no path to security. So what we did, I have a financial background. Our investors are from former NASDAQ. And so what we did said we need to bring something that's worked in the traditional market, and we need to modify it for blockchain. And so here's where the bridgeless interoperability works. If you've ever bought a stock through your Fidelity account or any other program, and you bought it from the Nikkei, you bought it from the NASDAQ, any sort of exchange, well, when Fidelity takes it in, they don't take ownership of the stock, depending on where it comes from. They basically have a deed that is the rights to the ownership of the stock. Now, this same mechanism works with NFTs. That we did not create, but we're utilizing. So with NFTs, you don't actually own the NFT. The blockchain owns the NFT, and it projects ownership onto you. So we already use the same mechanism in NFTs, is how the same thing that the financial system works for stock market. So what we've done is we said, we are going to keep all assets on chain. So bridging means that you are taking one asset from Ethereum or Solana, and you are going to take it over to Polygon, Tezos, wherever you're trying to do. That's bridging, and that's where the attack vector happens. So our interoperability keeps all assets where they are on their native chain and projects ownership up to a interoperability layer that allows all assets and all chains to interact with each other. The same way the stock market works, the same way NFTs work on an individual basis, we've created an entire layer. So that means once you've solved interoperability, now you can have a universal wallet, now you can have universal swaps, and you can have a secure layer that has there's no attack vector for exchanges. So that's the first thing. And then the second one is if you understand how blockchains work, For Ethereum, for example, or Polygon or Cardano or anybody else, you buy tokens. And those tokens are then held. Applications are built on top of that chain. And then when you interact with those applications, you have to pay the gas fee. So if you have Ethereum and you're on OpenSea buying NFTs or listing NFTs, you are paying a transaction fee every time that happens. So where the nodes come in, and this is the first, we're the first blockchain to be doing this, is we are allocating network resources to these nodes. And what that means is if you take two parallel identical companies, we'll use OpenSea since everyone knows the Ethereum network. If you have OpenSea on as A, in OpenSea A, every time you utilize it, you have to pay transaction fees. So that's how OpenSea normally works. Or if you have OpenSea B that functions like a Web 2 product where all users have no gas fee, which of the OpenSeas is going to have the most users and the most growth? It's going to be the Web 2 OpenSea that doesn't have any transaction fees or barriers for your user to get into. So that means that's where network resources come in. So with network resources, through the nodes, you can whitelist your address, and then when you build a product on top of our network, you are allocating network fees to the product, so it is a Web 2 experience in a Web 3 product. That's how the future of blockchain is going to be. It's going to be a Web 2 experience with full blockchains powering it underneath, and with free interactions for your users. Now, we have 3 tiers, and I have a good amount of time here, so I want to get into consensus mechanisms as well. So not only do you get network resources that are regenerative and last forever, you also get token allocation through the nodes that are, depending on what kind of node that you want, has a corresponding vesting period of the nodes. And the third is consensus. So a lot of people, if we've already decentralized our technology, what's left? We have to decentralize the consensus mechanism, like how votes happen, how things get approved to like improvement proposals that Ethereum has. So far, everyone's gone the route where if you have the most money, then and you own the most tokens of a particular network, then you get to decide the outcome of the network. And we said that may be how it is right now, but that's not good enough. That is still centralization. So if you look at EOS, for example, EOS had their token sale, but then Block One, which is the biggest company, was pretty much the kingmaker for EOS. And so they decided the future path on their own. What we've said is our tier 1 nodes, not only do you get network resources, and not only are you governors, but you have to, we have to vote for the council. So even if you sit on a node, you have proxies that get voted for and approved. So even if you are Amazon and you are on our tier 1 node, you have to submit candidates that the rest of the node holders get to vote on and approve. And that proxy may not vote the way that Amazon itself would want the proxy to vote. That's the way that we've decentralized it like more than anyone else has done right now. Because there's always, your network is always acceptable to the value of the network. So for example, if Hedera Hashgraph has a great consensus mechanism, they've appointed very high net worth companies, multinationals, to sit on their board. Okay, well imagine that works and that is a step forward, but it's not the ultimate solution. So if the value of Hedera Hashgraph ends up being $15 trillion, and the value of the collective network of the multinationals is only $3 trillion, they are going to start acting in the best interest of their company, not Hedera Hashgraph. So I'm running out of time, but I want you guys to know that, number one, we have thought of everything through and through in every aspect, from the blockchain to the protocols to the consensus to the gamification of the token. We have taken a giant step forward in each direction. And if you want more information, please get the QR code. It'll give you the link to our node sale. And we'd be more than happy for you guys to participate in our network. Thank you.